Hello everyone, welcome to the course Design Practice. In lecture module 28 and 29, we are discussing about what are the steps involved in a material selection, and till now we have already learned the first two steps, that is the translation and screening methods that is required in a material selection process. Now in this lecture module I will discuss remaining two steps that is involved in a selection process, and those steps are ranking method and comparison with your existing information. Now we will discuss in this module about screening by applying attribute limits, that is the Ashby method. Okay. In this method what happens, suppose that in translation steps we got some optimized value that material for particular application should be such that their elastic modulus is higher than 10 gigapascal and material density will be lower than 3 megagram per meter cube. Okay. So, these values came from translation steps. Okay. Now, after getting these value, now we have a variety of materials. So, how we will screen materials for our particular requirement? So, we will take help of Ashby chart, that is called Ashby material chart. Okay. Here what we can see that this is the plot between Young's modulus versus density, and they are the log plot. Okay. So, suppose that our constraint is E should be greater than 10 gigapascal. So, there will be a line, we can draw a horizontal line parallel to x axis corresponding to 10 gigapascal. Then another value which we got, density should be lesser than 3 megagram per meter cube. Okay. And 3 will be somewhere here. Okay. So, again we will plot one line that will be parallel to y axis. Okay. So, now you can see that in material chart there are variety of material placed at different location. Woods has a around 8 gigapascal Young's modulus and density is very low compared to polymers. Okay. So, what we have, density should be lesser than 3, then it means our region, search region will be this one. Okay. And whatever material will lie between in this region, all material will be selected candidate. Suppose that here one thing is mentioned, that is composite, it means selected candidate is composite for a particular requirement. Okay. It means now what we are seeing, we are eliminating ceramic, metal, polymers, elastomer, foam, wood, etc. These materials we have simply eliminated using the Ashby material chart. Okay, for particular condition. So, this is the simplest way to screening the material, and we can say that eliminating the non usable material that is not suitable for, these materials are not suitable for particular application. Okay. Although these have a very good property, polymers have a good property, metal has a very high strength, ceramic has a very high strength, but you can see here that for particular region these are the useless. Okay. Now, another material property chart you can take in a broad manner, you can take in this, you can see here for density versus strength there are a variety of materials lies between them, that is the you can this is another type, it is called material index. Another way it is called material index. Okay. You can take help of this plot, either Young's modulus or density or strength versus density plot. Okay. Here you can see lot of materials are given there. Okay. Now, third step is the ranking. Okay, after eliminating the several materials from the for our requirement, now whatever material we found that in that search region, suppose that was our search region in that plot, that was our search region. So, whatever material, suppose that M1, M2, M3 material is there, okay, in this region. So, now which one is best? So, rank on objective. Okay, objective defines performance matrix. Okay. So, what we will do to decide which material will be most suitable for our requirement, from we have M1, M2, M3, M4, 4 type of materials which can fulfill our criteria. So, there are several methods are available for to rank these materials, so that best can be come out from these. Okay. So, first method is using ranking using material index. This is the very simple way to represent the to rank the material. In this approach, here you can see that the for example, for tie rod, minimum weight stiffness prescribed. So, for tie rod and for lighter weight and stiffed material, the E by rho is equal to C. Okay. And by taking log, what we did, we got log E is equal to log rho plus and log C, and same thing is plotted here. Okay. Now, I will tell you the significance of this line on material chart. Okay. Suppose that we have 3 material M1, M2 and M3. Okay. So, what happens, the line, whatever material which lie on the line, that will be the suitable material for design. And the material which lie below the line, suppose for example M1, that is the worst material. So, you do not use. Okay. And for M3, which is light above the constant line, then this is called E by rho is equal to C line. That is the better materials. Okay. So, using this plot, what we are doing, we are doing two kind of thing. First, whatever the material which is lie below the line with this constant line, we just discard this material. This is not usable for our design. Okay. So, now we have a two option M3 and M2, either we can use M2 or M3. Okay. So, if suppose that we have M2 and M3, two materials. Okay. So, now we will have to check different criteria for selecting the best material. Either you can check cost, or since your goal is to make lighter in weight, so accordingly we can choose the material. Okay. Either M2 or M3. This is the selection of material based on the material index. Okay. Now, second method of ranking is that weighted properties method. In this method, what did it? In this method, each material requirement is assigned a certain weight depending on its importance. Okay. And a weighted property value is obtained by multiplying the scaled value of the property by the weighting factor. Okay. These are the terms which is to be used in this method: weighting factor and scaling factor. And the weighted property value of each material are then summed to give a performance index. The material with the highest performance index is optimum for the application. Okay. So, in this method, our goal is to make a performance index using the weighting factor and scaling factor. Okay. So, first, okay, here B is equal to scaled property. So, numerical value of property and maximum value in the list. Suppose that after screening you found that there is a M1, M2 and M3, 3 materials are suitable for design. Okay. Then what you will do, you just judge these materials on properties basis. Okay. So, you calculate for each material scale property. So, how you will calculate? There is a numerical value of the property. Suppose that each has a density rho 1 is equal to 100 kilogram per meter cube, rho 2 is equal to something like that 150, or rho 3 is equal to 500 kilogram per meter cube. Now, so in this list what is the maximum? 500 kilogram per meter cube. So, and if you are calculating a scale property for M1, then what will happen? 100 into 100 divided by 500. Okay. For M2, 150 into 100 by 500, and for M3, 500 into 100 by 500. It means you are just scaling the all materials, suitable materials. Okay. Now, and you can also scale your material based on the cost, corrosion loss, etc. And you know, cost is a very, it plays predominant role in material selection. Okay. So, you can't ignore the cost of the material. So, on based of cost, what will be desirable? A lower value is more desirable, and the lowest value is rated as 100. So, in that case, you will find unit cost per strength, means unit cost for to fabrication of each material M1, M2, M3. Then suppose that you are calculating, you are scaling the for M1 material, then minimum value in the list, whatever the minimum cost for any material, you will put here, then numerical value of that particular material, and after from calculating using this formula you can calculate the scale property. Okay. Now, so then after calculating the scale property, then what we will our goal is to calculate material performance index. Okay. So, how we will calculate? We calculated this one, scale property. Now, here as the line says weighted properties method. Okay. So, you will have to assign certain weightage M1, M2 and M3. Suppose that you decided that its weightage will be 30, 40% and 30%. Okay. And this weightage is based on material chart, or you can say material index. Okay. Now, as well as as per your requirement. Okay. So, after that for each material you have a scale property as well as weighting factor. Then you just using this formula you calculate overall material performance index. Okay. Now, you can make a table, and you will find that B1 alpha 1, B1 alpha 1, B2 alpha 2, B3 alpha 3, for each material you will get some value, and from this table you can easily screen out which material will be most suitable for you. Okay. That is the weighted properties method, and it requires for since for simplification process we consider only 3 material, but in a actual practice you will get around 10 to 50 something like that group materials which are suitable for your design. Then at that moment these calculations are very time consuming. So, for this purpose specific software and computer you can take a help from computer, so that you can find out the most appropriate material for your design. Okay. That is the ranking method. Now, after ranking After ranking, you will have to again recheck. Okay. Now till now what we did, first we did translation, then after translation of problem we just screening out some eliminated some material in a screening steps. After that we ranked each selected material, that is called ranking steps. And now you have a now after following these steps you have optimized material for specific product. Okay. So, but after optimization you achieved, you got material, appropriate material for your design, but yeah, whether you will have to ensure whether your selection is right, you will have to perform comparison. Okay. Now, question is that comparison with what? How you will compare your result? Okay. So, there are variety of methods are available, so that you can compare your result, but few methods are, that is the step 4. Okay. Here what you are doing, you are taking help of supporting information. Yeah. So, supporting information, their textbook are available here, good for general information. Everything has a certain advantage and disadvantage both. Some have table of properties, not good for detailed specification and property, a useful first point of call. Okay. And if you are taking help from data book, then one of the quickest source of detailed information, usually contain grades and specification as well as property. Small and perfectly formed pocket book like that, you can install it in you can see this in your iPad, mobile, etc. Easy to navigate around. Internet site, yeah, internet site can be real minefield, yeah, it is true, but lots of poorly presented information, because nobody has control on internet. Everybody can upload anything and maybe good or wrong information on internet, and if you will do Google search, then it may be possible that you may find at in the first attempt that wrong information, and if you will compare your optimized result with that wrong information, so that your design will get failed. So, hard to find technical information, best to use non-commercial sites. You can also follow manufacturers literature. Suppose that you are going to make a pen, so that already variety of pen are available in market, which are fabricated by various industry. So, you can take help variable in quality and usefulness, often only cover their product. Usually do not compare material, because these manufacturer what they show only their good thing, not limitation or bad thing. Okay. So, if you will compare with your results with these data, so you may find that some may be possible that you have done something good, but after comparing this literature you may think like I have done some wrong thing. So, it can be biased, good for final selection before ordering. Okay. So, there are variety of sources are available to compare your result, but after that at the end we can say that expertise matters. In material selection, so that you can, if you have expertise in this area, so you can always choose a good material for your fabrication of your product. Okay. Now, this is a case study of a bike. This is a one real value problem. So, you can see goal is to make a bike. Okay, bike. So what you based on your previous our discussion, what you have to do, first you will have to decide what is the function of a bike. Okay. So what does the function depends on the types of bike. Variety of types of bikes are available for depend on your application, racing for racing purpose, touring purpose, mountain bike, commuter, child, and for each purpose the design is there is a variation in designing of bicycle. Okay. So first you will have to decide whatever you are designing, okay, what you are going to fabricate, what will be its main purpose. Suppose that you are going to make a bike for mountain bike. Okay. So you will have to design accordingly, because in mountain bike there should be, for example, there should be some shock absorber here, tire should be higher thicker tire, and spokes should be some thicker, so that strength will be high, gear system should be there. Okay. So these kind of things matters in mountain bike. So you will have to choose every so first to make a mountain bike, what you have to do, first you will have to divide it in a component. Okay. So each cycle has a frame, fork, wheel, saddle, and suppose that for mountain bike you will have to gear assembly, shock absorber, these kind of things are required for to fabricate a mountain bike. Okay. So now suppose that if you want to select a material, appropriate material for frame, so what you will do, frame has a purpose. What purpose? Earlier I told you, this is the, suppose that frame for your cycle. So its purpose is to carry a load and as well as to support the wheels. Okay. These kind of things are okay. So material selection for frame. So for initial screening, when you will do initial screening, you will find that there are a variety of materials and it will are used for fabrication of frame, and this frame is not a new, because lot of companies are already fabricating this frame using either this material, steel, aluminum, composite, but in your particular problem you have to decide which material will be appropriate for your particular bike. Okay. So suppose that for if you want to make a frame using steel, so their properties of steel are strong, stiff, heavy but cheaper cost related. Aluminum weaker, lighter, more expensive than steel. Composite strong, stiff, very light but expensive to buy and to fabricate. Okay. So sometimes when if you are designing something for a specific purpose, so sometime you will have to sacrifice your cost. Okay. You will have to pay more to get a better thing. Okay. Here you can say that if you will use aluminum rather than steel, so it will be very lighter weight. Okay. That will be very beneficial for mountain bike, but cost is higher than the steel. So you will have to sacrifice sometimes cost. Okay. So in your this is your again home assignment. For practice only. Okay. Okay, you just think how you will make a mountain bike, okay, and which material will be appropriate for what component. Okay. And using what I discussed with you, there are 4 steps: translation, material selection steps, then you do screening, then you do ranking and compare. Okay. You can simply follow these steps to select materials for your mountain bike. So you can do it in home, and this is for only practice purpose. Okay. Now I am going to close this lecture module for material selection in engineering design, and in next class we will discuss something else. Okay. Thank you very much.